The Earth's surface is made of rock. But you don't have to travel the world to study rocks. They're on your doorstep. Buildings are made of rocks which were once part of the Earth's crust. A town centre is an ideal place to start studying them.
Right. Hidden in the rocks are clues as to how they're formed. These are going to be some of the things that you're going to try and look out for as we walk around town.
Oh, look, a crystal. Fossils. Shells.
There's also sand grains. All we need now for our field trip is a sponge, some water, and some magnifying plates. Let's go and look at some rocks then.
Yeah.
Come on.
There are three types of rock to look out for. The most colourful can often be found on the front of banks. Architects use them because they're so attractive.
They're all different colours. Sparkly too. There's white, and there's some black. Some grey as well.
This rock is made up of different coloured crystals, which is our first clue to what type of rock it is.
If you look, there aren't any gaps. They're all interlocking.
This is rock type number 1, igneous. The clues telling us it's an igneous rock are crystals and no gaps.
So in igneous rocks, each different coloured crystal is actually a mineral.
So what minerals are these?
This long pink one, they're a mineral called felspar. And then the grey glassy coloured minerals, they're quartz. But the very small black shiny minerals that you can see, they're called mica.
Rocks made up of these three minerals belong to a type of igneous rock called granite.
This bit's all smooth, like it's been polished. But this bit, it's all dull and rough. Like the rock would be in the ground.
Rocks look much duller when they're still in the Earth's crust. So how can you tell this is another igneous rock?
Now you've wiped it, you can actually see all the crystals.
They're quite hard to see. Yeah, they're a lot smaller.
In years gone by, some cobbled streets were made out of igneous rocks, like granite. What does this tell you about these rocks? Igneous rocks are formed when molten rock cools and solidifies. The name comes from the Latin word ignis, meaning fire. Volcanoes happen at a weakness in the Earth's crust. The crust is very thin compared to the size of the whole Earth. Below it lies the mantle, an enormous layer of solid rock, which in some places gets hot enough to melt. A volcano erupts when this molten rock or magma is forced upwards and out. It forces its way to the surface through cracks in the crust and pours out as lava. The lava cools, and over time a cone-shaped mound of newly formed rock builds up. The speed at which the lava cools determines which kind of igneous rock is formed. These two rocks both came out of the top of a volcano, but they're totally different.
It's really light. It's kind of like a sponge, but it's hard. This one's all jagged. It's heavy. It's a nice colour. It looks like coal, but it's not coal.
Well, first of all, this one. It's really light, isn't it? This was actually spurted out the top of a volcano really quickly. I suppose it's a bit like a bottle of fizzy water, really. It's got loads of bubbles in it. If this was frozen, all those bubbles would stay in it and you'd see spaces. Just like the spaces in this. They're just loads of air pockets that have been frozen when this cooled. This is even light enough to float.
It's called pumice. It's too light to be used for building, much better at getting that rough skin off your feet. On the other hand, this igneous rock, basalt, is much tougher.
This one's really, really heavy, isn't it? It's heavy because there aren't any holes in it. There aren't any gas bubbles. It was actually erupted quite slowly out the top of the volcano. This one won't float.
While basalt and pumice are two rocks formed from lava erupting out of a volcano, most igneous rocks are formed deep underground. This happens when the molten rock doesn't make it to the surface. It forces its way into existing rocks, cools down, and crystals begin to grow as it solidifies. This is how igneous rocks like granite are formed. So how does the rate of cooling affect the crystals? The magician is using a chemical called salol. When placed in a warm water bath, it changes from a solid to a liquid. Sandwich in a small amount between two sheets of cold glass, and you can see how quickly the liquid solidifies. It crystallises. But each of the crystals is quite small. If the glass is warm instead of cold, the salol cools down and crystallises much more slowly. The slower the cooling, the bigger the crystals. The crystals in this rock are quite small, especially compared to the crystals in this one. Which igneous rock cooled more slowly? Believe it or not, the rolling countryside of Cornwall in southwest England used to look more like the Himalayas or the Alps. Mountains don't last forever. They gradually wear away at a rate of about 10 centimetres every 1,000 years. So all that's left in Cornwall today is a series of domed shapes, giving the landscape its rolling appearance. Changes in temperature from day to night and the expansion of freezing water cause rocks to wear